Hi, welcome back to LeetCode. So in this video, I am going to discuss the first problem from today's weekly contest 488. The first problem is name is count dominant indices. So you are given an integer array nums of length n. An element at index I is called dominant if nums of I is greater than average of nums of I plus 1, nums of I plus 2 till the nums of n minus 1. Your task is to count the number of indices I such that that are actually dominant. The average of a set of numbers is the value obtained by adding all the numbers together and dividing the sum of the total numbers, number of numbers. So, and then mention that the rightmost element of an array is not dominant because there is no element in the right side of that, because this is the last element of the array and there is no element on the right side of that. So it cannot be a dominant index, right? So that's why they mention that. So let's take this example 1, 5, 4, 3. Okay, 5, 4, 3. Okay, so first of all they mention that this 3 will not be a dominant. Now I want to know that this actually 4 actually is dominant or not, right? So what is the condition for dominant? That 4 should be greater than average of 3, because in the right side of 4 there is only one element, that is 3. So what is the average for this only one number? That will be the sum of that and number of so what is the average? Average is the sum of all the numbers by the how many numbers is present. So here actually you can see that only one number is present, so sum will be 3 and n will be 1 1, because only one number is present, so average will be 3. Okay, so now to check that 4 is greater than 3, yes, so this is a dominant. This is dominant. Now I want to check that this 5 is actually dominant or not. Okay, so what is the condition for to be dominant? The condition is 5 should be greater than average of 4 and 3, because in case of 5, which element present or right side of this, that is 4 and 3. So what will be average for 4 and 3? It will be sum of this 4 plus 3, and how many actually element is present? 2. So that will be 7 by 2, it is 3.5. So yes, 5 is greater than 3.5. So this is also a dominant indices. So is there any element left? No. So our answer will be 2, because 2 element actually I found that 2 indices actually I found that actually dominant. So that's the answer should be 2. Let's check output of this example 1. For this example 543, the output is 2. Let's take another example 412. Okay, 412. 412. They mention that this cannot be our rightmost element, cannot be a dominant indices, right? So that's why we don't need to calculate that. I can start from here. So I'll start from this one. So so our condition is to be a dominant is that 1 should be greater than average of 2, because there is only one element present right side of that. So average of 2, it will be 2, right? So is 1 greater than 2? No. So this cannot be a dominant indices. Okay. Next, come to this number 4. So condition to be dominant is that 4 should be greater than average of 1 and 2. So what is the average for 1 and 2? That is 1 plus 2 by 2. It is actually 3 by 2. That is actually 1.5. So 4 is greater than 1.5. Yes. So this is a dominant index. So our answer will be 1, because I found only one index, right? That actually dominant. Got it? So in this actually we have to check that which index actually is dominant or not. So what is the brute force approach we can think? Suppose we actually have n1, n2, n3, n4 in this way actually. Okay. So if I want to check that this n1 is a dominant or not, so what to check that n1 is greater than average of n2 plus n3 dot dot till suppose n by suppose actually n minus 1 number actually is present, because here starting with 2, 3, second element, third element, it go up to n. So only n minus 1 number actually is present, right? So average of this, if I check that if n1 is greater than this, so I'll actually count this, our answer will be increased by 1. Our answer will initially is 0, and whenever actually it's satisfying any for any index it is satisfying this condition, I'll actually increase by 1 in this way, correct? So this is a brute force approach. So what will time study for this approach? So suppose we actually have n numbers. So for each index I have to first calculate the sum of all elements present in I plus 1 to n minus 1. So it will take actually roughly big of n, because I have to calculate the average. So that's why I will calculate the sum by n minus 1, something like. Okay. So this is I have to calculate for each I, and how many I is possible? I is possible from 0 to n minus 1. Alright. So for each I have to calculate this sum, and first I will calculate the sum and the average, then average. So that's why it will actually take big of n into big of n. First big of n is for outer to fix the I. For ith index, I am going to calculate, check that this is actually a dominant index or not. So that can be vary from 0 to n minus 1 average case. And for each index as I have to check that is actually satisfying, it is actually dominant or not. So to calculate, to check that this is dominant or not, we have to calculate first the sum of all the elements present on the right side of that. So that's why we have to iterate from I plus 1 to till n minus 1. So that's why to calculate the sum, it will take big of n, and then it will calculate the average sum by how many element is present. Okay. So that's why it will time study for this approach, it will be big of n into big of n. That means big of n square. Clear? Now I can optimize this. How? So by using the suffix sum, actually, kind of. Suppose we actually have, let's take the first example again. 5 4 3. Okay. 5 4 3. So you can observe one thing. I know that this cannot be our answer. Okay. Now I'll come to this number 4. So for 4, what actually I want to know? I want to know the sum of I plus 1 to till n minus 1 by how much number is present? Roughly n, suppose. So that means I want to know the sum from n minus 1 to till this I plus 1, right? That means I want to know the sum from this to this, that means 3 only. Next, I am trying to calculate 5, then I want to know the sum from 4 to 3, correct? If actually I am present at the ith index, I want to know the sum of from I plus 1 to n minus 1 till, correct? That is correct. I am present at index 5, sorry, no, index 0. I want to know the sum of from index 1 to 2. Here actually index 0, 1, 2. I want to know the sum of from 1 to 2, correct? So that means if I am currently in ith index, I want to know the sum of I plus 1 to n minus till n minus 1, correct? That is what I want to know. Can I actually optimize this? Because I cannot, because every time I have to check for each index that from 0th index it is dominant or not, 1 in the first index is dominant or not. But we cannot optimize that because every time we would check that. But sum actually we can optimize this sum, because I know that in this brute force approach, to calculate the average, I have to iterate the right side of all the elements present on the right side of that. So that will take big of n. Alright. So for that actually we can use the suffix array. So suffix sum, that means suppose we actually have 5 4 3, 5 4 3 suffix. So till 3 I will iterate from right to left. Okay, right to left. So for 3, what is the sum for this? 3, because there is no element in the right side of it. But for 4, what actually I will store? I will store 4 plus 3, that is 7. Okay. For 5, I will store what? 5 plus 4 plus 3, right? That is what I want to store. But how this is 4 plus 3, what? This. So directly I can access that 5 plus suffix of I plus 1. Got it? In this we can efficiently actually calculate the suffix or any sum from I plus 1 or any index from any index I to n minus 1 by using the suffix array, correct? So that means if actually create a suffix array, okay, so this is a size of 3, okay. So for this this is 0th index, first index, second index. Okay, for second index our some suffix array will be look like 3. Then actually suffix array for index 1, it will be what? The current value, that is 4 plus suffix of I plus 1, that actually index 2, that is 3. So that means 4 plus 3, it is 7. Okay, now actually I want to calculate the suffix sum of this index 0. That means current value that is present in the index 0, that is actually 5. Okay, and suffix of I plus 1, that means I value is 0, 0 plus 1, so I'll come to this value, that actually 7. So 5 plus 7 is actually 12. Got it? This is a suffix array look like. It will show 12, 7, 3. Got it? Now actually you can see that in constant time we can calculate what is the sum of all the elements present at the right side of any index I. Suppose I want to know the, and what is the actual array? 5, 4, 3. 5, 4, 3. This is actual array, and this is the suffix array. 12, 7, 3. Okay. Suppose currently I am at index 5. Okay. Now I want to know that index 0 and current number is 5. So I want to check that this index 0 is a dominant or not. So what is the condition for to be a dominant? That 5 should be greater than average of sum of I plus 1 to till n minus 1 by how many numbers is present. So what is the sum of I plus 1 to n minus 1? That actually you can easily find out from this. That is 7. Correct? From suffix array. Currently I have ith index. Here actually ith value is 0. Value of I is 0. And if I go to the next object I plus 1, you can see that I have stored the sum of all the numbers present on the right side of that. That is 7. So I can, in constant time we can actually get these values. Got it? So this is 7. Now how much element present right side of that? I know the total element present is n. So here actually n is equal to 3. And currently I am at ith index. So total number actually is present, that is 3. And currently ith value is 0. Okay. That means how many elements present right side of that? That is 3 minus I plus 1. So 3 minus 0 minus 1, that is 2. So why actually I plus 1? I am currently ith index. Here actually we have actually 0 based index. So that's why if actually ith index, that means actually this how it is the suppose ith element, correct, ith element, but it is 0 based. So that's why I have to know I have to add plus 1 to be one based index. And how much element present right side of that? Total number actually n minus I plus 1, n minus of I plus 1. Clear? Ultimately it is 2. Clear? So we can actually constant time we can calculate what is the average for suppose I plus 1 to n minus 1. Got it? So from big of n to big of 1 we can actually optimize that, right? So I hope this is clear, the strategy approach. Now go to code. So for that, first of all, calculate the how many element is present, how many numbers. So n will be the nums of dot size, whatever the input array nums dot size, and this float is the, why actually I have to take the float, because it may possible that say 5 is our current element, and in average it can actually have actually decimal suppose point value, right, decimal value. So that's why we have to take this float to actually compare with this right? You all know that suppose 3.5 is greater than 3. So suppose our current element is 3.5 and average I got actually 3. So somehow we have to compare that, yes, 3.5 is greater than 3. So that's why we need to actually compare with the float value also, right? So that's why I initialize this suffix value as 0 in all the index. Actually n index is possible, so that's why I will take size as n. And you can see that for the last index n minus 1, our suffix sum is the same, whatever the number is present at the n minus 1 index. Got it? Why actually? Because there is no element on the right side of that. This is the first element. And for other indices, what will happen? We actually have current element also, and we have sum element on the right side. So what is the sum I will get from the right side? We can actually access from the suffix array. So you can see that here I will start from iterate from n minus 2, and I'll go up to 0, right to left, I minus minus. Got it? And now suffix sum of current index I, it will be what? Current num, whatever the value present at the ith index, plus what is the suffix sum of I plus 1 index. Correct? I will add these two and store in the ith index. Now you can observe that in ith index we actually have the total sum of from ith index to n minus 1. Ith index, this is the current number present in the ith index, and what is the sum of the I plus 1 to n minus 1 that I will get from the suffix array, suffix sum array. Got it? So after this for loop we have generated this array, 12 7 3. Okay, now I have to check that which index actually it is actually dominant or not. So we have to return the count of that, so that's why I will initialize to is 0 answer. Okay, now I will start from 0 and I will go up to n minus 2. Why? Because they mentioned that n minus 1, the last index cannot be our answer, a dominant index. So that's why I will go up to n minus 2. So that's why I'll start from 0 and less than n minus 1. That means I'll go up to n minus 2 and I plus plus. Now I have to calculate the what is the condition to be dominant, that the average, the current number should be greater than the average of I plus 1 index to n minus 1. So that's why first we'll calculate the average of that. So average will be what? The suffix sum of I plus 1. Got it? So that means this suffix array of at the I plus 1 index, it indicates that whatever sum of numbers present from I plus 1 index to n minus 1. Correct? That is actually I want to know here. Here actually you can see that the average is nums of I plus 1, I plus 2 till n minus 1. That actually I want to know the sum of that, right? So in constant time we can actually get the that value, the sum of all the number present on the right side of that. And now we have to calculate the average. So that's why what is the length of the how much number present right side of that? That is why I calculate from this n minus n is the total number actually present, I is the ith index currently I am at, and minus 1, because I already explained why actually I have to add minus 1, because I have to ultimately I plus 1, and if I subtract it, ultimately all are actually negative now. 3 minus I minus 1. Clear? So in this actually I will calculate the average and I will check that the current number nums I is greater than this average or not. If it is greater than that, I will actually increase our answer, because this is one valid dominant index. So that's why I will increase that. And ultimately after checking all of these indices, I will actually return whatever the answer actually I actually have. Got it? So here actually you can see that this will take big of n, triangle study, big of n, and here also it will take big of n. So ultimate triangle study will be big of n. So I think brute force approach will work, because our here actually nums length is 100. So that's the n square approach will also work. But I actually explained the optimized approach by using suffix array, because suffix array is an important topic to understand actually, and also we have seen many problems how actually we can actually use suffix array. That's why actually I use this approach here. So to subscribe the channel, please subscribe the channel, sorry. And yeah, I have shared this code in the description, you can check that also. Bye bye.